Okay, good day. This is Math 140 College Algebra. I'm Professor McCulley, and this is lesson 2.5 on parent functions and transformations. Let's get right to it. Today we're going to identify the following functions: a linear function, squaring function, cubic function, square root function, and the reciprocal functions. And we're going to graph some following functions using slide transformations and reflections. So let's talk about some of these things. Some common parent functions, and these aren't the only ones. The book lists these common functions on page 122 through 124. The book's description includes domain and range, even, odd information, increasing, decreasing intervals, and symmetry if applicable. I'm just going to kind of go through some of these just real quick. And draw some simple graphs. These aren't rigorous enough as answers for um, questions on quizzes, but for the sake of us getting to be able to recognize what some of these looks like, these should be okay. So the constant function, just as a real quick one, a constant function is something like y equal to x. Actually, that's not a constant function. Y equal to 3, and we know that y equals to 3 is a horizontal line. And so anytime you see f of x equaling to a constant of some sort, it is going to be a horizontal line that passes the y-axis through that constant. The simple function um, uh, f of x is equal to x is a simple linear equation, and it is a simple linear equation that has a slope of 1 and a y-intercept of 0, and we can see that. So the slope is 1, the y-intercept is equal to 0. The squaring function, let's delete this thing. If I were to make a quick table of values, this is a parabola. It has no linear term. It has no constant term. So if I plugged in 0, I'd get 0 out. If I plugged in 1, 1 squared is 1, 2 squared is 4. Negative 1 squared is 1, negative 2 squared is 4. So I get a graph that looks like a very simple parabola. And some of these values will be important when we talk about transformations. This 0, 0, 1, 1, 2, 2, 4, negative 1, 1, and negative 2, 4. And then the absolute value function, just real quick, the absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of 3 is 3. And the absolute value of negative 1 is 1. The absolute value of negative 2 is 2. The absolute value of 3 is, or negative 3 is 3. And so that particular graph would be a V shape that looks kind of like that. And let's undo all this stuff, clear this out. The square root function, remember, we can't take the square root of a negative number, so this one's going to have some domain limitations, and I can't plug any negative value into it. The smallest value I can plug into this function is 0, so I'll have 0, 0. I can plug in 1, and so the square root of 1 is 1. I can plug in a bunch of values, but not every value is a perfect square, so when I take the square root, I'll get some decimal. But the square root of 4 is 2, and I don't have it on this graph, but the square root of 9 would be 3. So that graph is going to look something like that. The x to the third function right here, just some quick ones that I can plug in. Negative 1 raised to the third power is negative 1. 0 raised to the third power is 0. 1 raised to the third power is 1. 2 raised to the third power is actually 8, so it would be way up here. And negative 2 raised to the third power would be negative 8, so it would be way down here. So we get a graph that looks kind of like this for our cube function. And then lastly, our reciprocal function. If I plug in 0, I get a division by 0. So I actually have an issue at 0. It's undefined at 0. At 1, 1 divided by 1 is 1. 1 divided by 2 is a half. 1 divided by 3 is a third. And so I keep dividing out, but I actually can never get 0 because remember, for a fraction to be 0, I have to have 0 in the numerator. And I can plug in, let's say I plug in a half. 1 divided by a half would be 2. 1 divided by a quarter would actually be 4. So I actually get a graph that's kind of funky. It kind of looks like this. And then the same thing happens with the negative values. I get this graph here that never touches either of the axis. Now this really should go through that point there, but just a little bit of an issue. So those are the general shapes. And again, I suggest that you take a look at them on the pages 122 through 124 in your text. Now we want to talk about transformations, some common transformations. Now, if you took Honors Algebra 2 for me, you've seen this list before. I actually copied and pasted it from an Honors Algebra 2 lesson. But if you talk about f of x being a function, and you take that function and create a new function h by adding some constant, that is going to translate into a vertical translation of c units up. Now, if you have h of x and you add to the variable inside before you do the function, that is going to be a translation c units to the left. And we're going to see that in all of the cases, whenever you do a change something to the variable, it's going to kind of be the opposite of what your intuition might think. And if we need to discuss that in class, we can do that. If I make the variable negative, all the variables negative, that's going to be a reflection about the y-axis. If I make the function negative, that's going to be a reflection about the x-axis. Those are all of the rigid transformations. There are a couple non-rigid transformations, and they're not necessarily part of this lesson, but you may see them in the future. If I multiply the variable first by a constant, that's going to be a horizontal stretch by a factor of 1 over c. So if you multiply the variable by a constant, it's actually going to shrink how big the graph is. And I'm going to show you some examples of this on the graphing calculator here real shortly. And then if I multiply the function by a constant, the whole function, that's actually going to stretch it by a factor, not a factor. It's actually a factor of c. Professor McCulley is a factor. Anyway, let's take a look at some of this stuff on the graphing calculator. So let's pull up the graphing calculator. Let's clear out this, and let's do just one of the simple parent graphs. Let's do x quantity squared. Now, if I wanted to, so let's just take a quick look at the graph of that thing, and let's say trace. Oh, that works good enough for me. I'm just going to hit that graph. And so this is my original graph, and let's go down to the y2. If I go x squared and then I say plus 2, well, if I were to discuss how these transformations happen, the easiest way for me to do it is for me to like plug in a number and see what happens to that number as it goes through. So let's say I picked an x of say 3. 3 I would plug in and then I would square it. Well, that's the function, squaring the function. And then after I've done the function, I add 2. So to me, that thing looks like this first one. So that's going to be a translation 3 units up, and or 2 units up because I did a 2 there. And when I see that, I see it the exact same graph. It doesn't change in shape or anything. It just has moved up 2 units. Now, if I wanted to do the second one and do a transformation c units to the left, well, the way that would look is if let's clear this out, I did parentheses x plus 2 quantity squared. Now, if I were to pick a number, let's say I pick 4, x. If I go x plus 4, that's what you would do, or excuse me, if I plugged in 4, I go 4 plus 2, so I'm adding first. That's the first thing that's happening, and then after I get the 6, then it's going to square it, okay? And so that, in my mind, is this horizontal translation c units to the left. So clearly, when I hit the graph here, we notice that I have a graph that looks exactly the same in shape. It's a rigid transformation, but it's been shifted 2 units to the left. All right, if I want to do a reflection about the y-axis, I'm going to make the variable negative, so I can just go in here and delete this, and we'll just go negative x, and I hit graph. And in this particular instance, we get the same thing. And the reason that we get the same thing on this particular graph is because a reflection about the y-axis is going to take this part and lay it right on the other part. So this particular function, this x squared function, is symmetric about the y-axis. So um, that's why those two graphs lie upon each other. And then finally, if I want to do a reflection about the x-axis, I'm going to go y equals, and then down here, and then instead of putting it inside the parentheses, I'm going to put it outside the parenthesis, and there we see our reflection about the x-axis. Oops, didn't want to go there. Okay, so if I want to do horizontal stretches, this one isn't quite easy to see, but if I wanted to do a horizontal stretch, I come down here and I do a parenthesis, and then I go 2x like that, and I know it looks like it's been stretched vertically, but just think of it this way. This point right here, that's 2, 4, has been stretched horizontally by a factor of a half. So if it was 2, 4, it's now 1, 4. Now, when I do move that 2 to the outside, I'm going to do it in this green one. I'm going to go 2 parenthesis x parenthesis squared. All right, so this is going to stretch it vertically by a factor of 2. This was a stretch horizontally by a factor of a half. You'll notice that even though they both make it look skinnier, they're not the same. So stretching it up, it's taken this point 1, 1, and it's changed it to the point 1, 2. It's stretched it. The point 2, 4 has been stretched to the point 2, 8 right there. And so they are, even though they are similar, they are certainly different types of functions. All right, so let's talk some examples here. It says, given the graph of f of x, and so this thing right here is f of x. It says, sketch the graph of g of x, which is going to be f of x plus 2 minus 3. And so to me, if I were to take a number and plug it in, so let's say I picked like -2. -2 plus 2, so I'm adding to the function first. That's how I would evaluate it. And then I would do the function, and then I would subtract 3. So in my mind, I've got two transformations. I've got a shift 2 units let's redo that. Sorry. Shift 2 units left, and another shift 3 units, very good, down. All right, so I have this point here, it's a 0, 0. I have this point here, which is 1, 2, and I have this point here, 3, 3, and then this point right here, 4, 4. All right, if I have those points and I shift 2 units left and 3 units down, my new graph for g of x, if I talk about the x and y values, 0, 0, 2 to the left would make it -2, and 0, 3 units down would make it -3. So that's what I'm going to do to all of these points, since that's what I would do to 0, 0. So 1 minus 2 is going to give me -1. 2 minus 3 is also going to give me -1. 3 minus 2 will be 1, and then 3 minus 3 will be 0. I screwed this one up. This was I said it right and I wrote it incorrectly. Oh no. All right, let's see if I can get away. Nope, I'm not going to get away with it. So let's do this whole one again. -1, I need to subtract 2, so that'll make it -1. And then 2, I need to subtract 3, that'll be -1. There we go. This last point, 4, 4, I need to subtract 2 from the first 4, that'll give me 2. And when I subtract 3 from the 4, I'm going to get 1. So my new graph will be -2, -3, right there. -1, right there. 1, 0 right there. And 2, 1 right there. And then when I connect the dots, I get this. And so the shape of this one is exactly the same as the shape of this one because we only did rigid transformations, but it has been shifted left 2 units and down 2 units. All right, let's talk about this. For the following functions, A, state the parent function, then B, describe the transformations from the parent function to the given function. All right, so here, for this one right here, I see this x squared, and so my parent function, let's get my thing up, my tool, is going to be, I don't want to use f of x, so I'll use h of x equaling to x squared. And then this -3, well, in the last couple, when we added to the variable, that was a shift to the left 2 units. So when I subtract, that's going to be a shift 3 units right. And the last one, when I subtracted, that was down. So this is an F. Oh, shoot. I almost had a curse word on a school video, but that is an F. Anyway, this is going to be a shift 1 unit up. All right. So here we have this absolute value. So our parent function. I think this time I'll call it y equal to absolute value x. Like that. And so if I plug a number in, there's nothing that goes on to the variable beforehand. Take the absolute value of it, and then I make it negative. All right, so making the function negative, that's going to be a reflection in the x-axis. And then the +5 will be a shift 5 units up. All right. Let's see here. Given a parent function, a set of transformation, write the transform function. All right. So the parent function is going to be g of x is 1 over x, and then we want to reflect in the y-axis, and then we want to translate 2 units to the right. Oh, that one's going to be tough. All right. So my new function h of x is going to be 1 over. All right, so reflecting the y-axis, what is that going to do? Let's see here. Reflecting the y-axis, that's not it. Where did they all go? There we go. Reflecting the y-axis, I need to make the x value negative. Okay, so let's make that x value negative. And then when I translate 2 units to the right, we said that that was a plus. So +2 there, or actually we said that we would do a minus because we need to do the opposite. We're actually going to end up doing plus. I kind of gave it away. -2. But when I go to graph that thing, let's clear out all of this stuff here. Clear and go 1 divided by parenthesis -x -2, and I hit graph. This thing was actually a shift 2 units to the left. All right, but we said when you do minus, that means it's to the right. Well, we are combining some transformations here. We are combining some transformations. We're actually combining this reflection and then this horizontal translation. And we're combining multiplication and addition. And so what happens here is when you're combining, you should kind of always check, but just in general, this is a multiplication by -1, and this is an addition of C. So when I in the order of operations, multiplication is above addition, so it has a little bit more power. And so it's kind of like we're distributing a negative sign to two things. So you kind of got to think of it a little bit differently. and you should always check. But we end up here. Um, what we're actually doing is to undo this multiplication. We're actually kind of going x minus 2, and then we're making this shift negative. And so what that ends up being is when I distribute that negative to get rid of those two parentheses, it ends up being negative x plus 2. So if I go back to here and I hit my y equals and I change this to a plus here like that, now I get that shift 2 units to the left. All right, there. And so um, my final graph or my final function is going to, and this one was wrong, and I apologize for that, but this is the correct answer. And that's all I got for today, folks. So today's Marvel fun fact of the day: for Guardians of the Galaxy, Vin Diesel did the line "I am Groot" in Russian, Mandarin, Spanish, Portuguese, German, and French, so that when it was dubbed for all other audiences, they could still use Vin's voice. That's all I got for today, folks. Have a good day. Bye.